All right, example 6 in chapter 1 it says use the power principle to solve the square root of x plus 4 equals 3. So the square root of x plus 4 equals 3. What you have here with the square root is an understood index of 2. Every single radical there is has a little number in that little nook. When the 2 is the number, though, they don't usually write it. All right? So, oops, that's not what I wanted. Usually you see, for square root, it's just that picture. All right? The power principle states that if you raise both sides of an equation to the same power, you're creating sometimes an equivalent equation. Sometimes. We're going to make the assumption that we make an equivalent equation every time, but then we're going to have to verify solutions. All right? Anytime you do one of these problems and one of your tasks is raise both sides to the same power, know that whatever list of answers you get could possibly not work, and you have to throw out an answer or two when that happens. So we'll see that happening in at least one or two of the examples today. So in this case we have a square root, so squaring is going to fix it. If I want to square the left-hand side, I'm required to square the right-hand side. Square, not cube. I was trying to write a 2 and I was looking at the 3 and my brain didn't let me draw the 2 there. So anyway, square the left, square the right. On the left-hand side, when you square a square root, the leftover is whatever's inside. The contents of the radical get to be put down. That's actually rather simple. Okay, so the side that has the radical, when you raise it to the power, that's easy. Just make the radical go away. The other side sometimes gets more complicated. In this case, 3 squared is not very complicated, equals 9. Whatever you're left with once the radicals disappear, just use basic algebra. In this case, move the 4 to the right. So x equals 5. Okay, what x equals 5 represent is the proposed solution to the problem. Okay, and again, since I squared both sides, it doesn't necessarily mean it actually works. Some of these problems have no answer. Okay, but of all the numbers in the world, we just knocked off all but that one. Okay, so right here, any number could be the right answer. Once we got here, now this is the only number that could be the right answer. So now we're going to check to make sure it actually works. We're going to go back to the original problem right here, before we modified it whatsoever. Change x to 5 and see if it ends up being a true statement. 5 plus 4 is 9. Square root of 9 equals 3 is true, right? So that means I'm fine. Circle my answer and I'm done. If that said the square root of 9 equals negative 3, now I'm going to have to strike that out and call the empty set. Okay. Negative 3 times itself does equal 9, but this is the positive square root of 9 has to equal a positive number. All right. If it were negative square root of 9 equals positive 3, it's still not good. If it was negative square root of 9, it'd have to equal negative 3. So keep that in mind that you do always have to check your solutions. A lot of times they actually work, but sometimes they don't, and you do have to verify.